Okay, so we've already covered this, this. We are here right now, and I've covered this. Now at resonance, the first point to note is that at resonance, XL minus XC is equal to 0. And this implies that XL is equal to XC. Don't forget that. All right. Point number 2 is that at resonance, the phase angle, you can say phase difference, it depends on the context. All right. Phase angle is 0. That means that cos phi, which is cos 0, so cos 0 will be equal to 1. Is that okay? That's point number 2. Of course, we can prove this. If I want, I can use the right angle triangle we drew in our last video. This is phi. Okay, here you remember Z, here is R, and this is XL minus XC. So if we are to use tan phi will be equal to opposite, which is XL minus XC all over R, opposite over adjacent. So since this guy is equal to 0, that means tan phi is equal to 0. So 0 divided by R is 0. And of course, tan inverse, phi, which is equal to tan inverse of 0, will give you 0. Okay? So the phase difference or the phase angle is 0. Okay? Point number 3. Now, at resonance, current is maximum. And this means that impedance is minimum. Take note of that, very important. So you have maximum current flow through the circuit. All right. Now, point number 4, at resonance, the resonance frequency is given as 1 all over 2 pi root LC. Is that okay? Now you can as well write in terms of the angular frequency or angular velocity. Now in physics, we model up angular frequency with angular frequency. Angular frequency and angular velocity together, all right? We model them up. They share the same symbol. They share the same unit. So this symbol can mean angular frequency, can as well mean angular velocity. Is that okay? So angular frequency is equal to 1 over root LC. Now let me prove it. Okay, so you recall that we said XL is equal to XC, right? Look at it up here. Now this also means that omega L is equal to 1 over omega C. You remember? Okay, so it also means that 2 pi f L is equal to 1 over 2 pi fc. Okay, now if we cross multiply, okay, if we cross multiply, we'll get 4 pi squared f squared LC is equal to 1. Do you remember? Okay, that means f squared now, of course, once this is equal to this, you put naught on as the subscript. Okay, f squared will now be equal to 1 over 4 pi squared LC, like this. So I think I should finish it up here. Okay, so you notice that f naught will be what? Square root of 1 over 4 pi squared LC. Okay, I think I should make space. All right, so all right, so we can write this like this. F naught is equal to, remember, you can break this apart, root 1, and then can I do something like this? Root 4 pi squared times root LC. This is allowed in math, right? Okay, so F naught is equal to root 1 is 1, and then root 4 pi squared will give us 2 pi, and then we retain this one, LC. Is that okay? So what about this guy? This question says we should prove this. It's still the same thing. Now, if I remember that omega is equal to 2 pi, in this case, F naught, right? That means I can, okay, let me finish it up here. Okay, so that means I can plug in what I have as my F. So omega, okay, resonant angular velocity or angular frequency is equal to 2 pi. Now, instead of F naught, I'll remember that F naught is 1 all over 2 pi root LC, right? So that this 2 pi will cancel this 2 pi, and then that will give you this. Can you see how simple it is? Okay, so, okay, finally, this is where we are going to bring this to a halt. Solution. This question says we should find the resonance frequency, okay? Now, just record the formula. F naught is equal to 1 over 2 pi root LC. Is that okay? Now, we just plug in the values we have. Of course, we have no business with this guy, just this and this, all right? So F naught will be equal to 1 all over 2 pi times. So we have 8 millihenry is 8 times 10 raised to the power minus 3 times 5 millihenry, 5 microfarads rather, is 5 times 10 raised to the power minus 6. Okay, so 1 all over 2, you can plug in your pi, use pi as 3.142 if you like, and then times, and then punch your calculator, 8 times 10 raised to the power minus 3 times 5 times 10 raised to the power minus 6. All right, so if you punch it well, you should get something, all right? But the correct option is C. Now, if you want to see how I solve this without using calculator, check out question number 24. All right, I've already solved it in our series of 40 questions with respect to RLC series alternating current. All right, so check it out. You see how I solved this so that it doesn't consume much time. Bye.